Hello, dear friends. Let's go through today a chapter on permutations and combinations. So, what's this topic all about? This topic mainly deals with arrangement of objects from a group of objects in a certain order, or just selecting or choosing set of objects from a larger group of things. Arrangement of objects in a certain order is nothing but permutation, and selecting or choosing set of objects or things without any particular order is called as combination. For example, if we have to tell that people have to sit in a particular seating order or have to follow a certain sequence, then we call it as permutation. Another example is, say, if you're giving a pin number or a number lock, it has to follow a certain sequence. For example, if the pin number is 345, it has to be in the order 345, right? Say, in cases of combination, what's going to happen is, say, for example, fruit bowl. In a fruit bowl, order doesn't matter. Which fruit you put first or which fruit you put last doesn't matter. Ultimately, it's going to be a mixture of fruits. Similarly, if you have to form a team, right, doesn't matter which player you select first and which player comes last. The order absolutely doesn't matter when you're forming a team. So these are the examples of combination, right? So permutation, order matters. Combination, order doesn't matter. So let's take an example. Say we want to form a team of 11 cricketers. And we have 4 bowlers and 15 players. When I say 15 players, they include batsmen, wicketkeeper, all-rounder, all of them. And there are 4 bowlers specifically. So totally, we have 19 players, right? We have 19 players, and we have to select 11 players. Out of 19, we have to select 11 players. Now, what are the combinations? Say we can take 1 bowler and then 10 other players, right? This is one way. Another way is you can take 2 bowlers and 9 players. Another one is 3 bowlers, 8 players. Another one is 4 bowlers, 7 players. And then you can take 0 bowlers and all 11 other players, right? So what are the total number of ways of forming a team? There are 5 ways. 1, 2, 3, 4, 5 ways. 5 ways of team formation. Now, within a team, you have several arrangements that you can make. So, say take this particular option, right, where you choose 1 bowler and 10 other players. So you have to choose 1 bowler from 4 bowlers. So it can be one of the 4 bowlers. It can be, say, for example, Umesh, Kapil, Siraj, Vinay, any of these players. So how many ways are there? We have 4 ways. 4 ways to select 1 bowler, and then 10 players to select 10 players out of 15 players, right? Say X ways are there to select 10 players out of 15 players. Similarly, if you take second type of team formation, you have to select 2 bowlers, right? 2 bowlers can be, say, for example, we take Umesh, Kapil, or we can take Umesh, Siraj, or we can take Umesh, Vinay. Similarly, you can take Kapil, Siraj, Kapil, Vinay, right? Or Siraj, Vinay. So you have multiple combinations like this. And with each of this combination, you can choose 9 players, right? You will have each of this combination, you can choose 9 players, right? Say you have player 1, 2, 3. So you have 9 players out of 15 players. So how many combinations we have? We can take, say, this combination, Umesh and Kapil with player 1 to 9. Or we can take Umesh and Kapil with player 2 to 11. So we can take any combination right here. So internally within a team formation, you have multiple ways of arranging the bowlers and other players, right? Now in this case, what we do, we multiply. How do we get the total number of ways that you can arrange 1 bowler and 10 players? You'll have to multiply bowler arrangements and player arrangements, and then you'll get the total arrangements. Similarly, you can arrange for this particular team formation also. You'll get some number of arrangements here, say X for bowlers and Y for players, right? If you multiply both of this, you will get total number of arrangements for this particular team composition. With this, we have spoken about 2 main topics in the principle of counting. One is multiplication principle, and second thing is addition principle. Now, this is an addition principle. and this is multiplication principle. Now, how do you differentiate? In multiplication principle, there are operations that you do. For example, in this case, we have one operation is to choose a bowler. Second operation is to choose other player. Now there are two operations here. Both the operations are dependent on each other, right? Because it depends. If I choose one bowler here, then I have to choose 10 players. If I choose two bowlers here, then I have to choose 9 other players. So basically, both the operations are dependent on each other. In such cases, we use multiplication. And both these operations are required to form the final arrangement. But this operation of forming a team, all of these operations of forming a team are different. They're independent. Whether you form a team of one bowler with 10 players, or you form a team of two bowlers and 9 players, or you form a team of three bowlers and 8 players, they are not related to each other. It is the choices that we have. This is the choices that we have to form a team. So we have here 5 choices to form a team. So that's where addition principle is used. So these two are key principles to solve all permutations and combinations problem. We need to understand when we have to use addition and when we have to use multiplications. So let's talk about permutation. What is permutation? Permutation is nothing but the number of arrangements that we can make when we take r things at a time from n different objects or n different things. The previous example we saw about bowlers, right? We had 4 bowlers and we have to choose one bowler, right? So what is n here? N is equal to 4. And what is one bowler? This is nothing but r. R is equal to 1. So we are trying to pick up one bowler from 4 bowlers. So what will be the permutation here? It will be NPR. What is the formula for finding the total number of arrangements? It's given as NPR is equal to n factorial by n minus r factorial. What is factorial? Factorial is product of natural numbers. For example, we have 4 factorial. What would be 4 factorial? It will be product of all natural numbers decreasing from 4. 4 into 3 into 2 into 1. We'll have to stop when we reach 1. So this is 4 factorial. Similarly, if it is 5 factorial, it will be you start with 5 and you go on till 1. So this is 5 factorial. So NPR is n factorial by n minus r factorial. Now in the same bowler case, we have 4 bowlers. So NPR would be nothing but 4PR. R is equal to 1 because we are choosing one bowler. So if you apply this formula, it's going to be 4 factorial by 4 minus 1 factorial. What do we get? 4 into 3 into 2 into 1. 4 minus 1 is 3 factorial. We get 3 factorial, right? And 3 factorial is nothing but 3 into 2 into 1. So this will get cancelled. We'll get 4 as an answer. So what are the number of ways? It's 4. We have 4 ways of choosing one bowler from a set of 4 bowlers. There is one more shortcut to arrive at NPR. Say we have 4P2. So one direct way is what you'll do if you have 4P2, you'll write as 4 factorial by 4 minus 2 factorial, which is 4 into 3 into 2 into 1 by 4 minus 2 is 2 factorial. 2 factorial is 2 into 1, correct? Now if I cancel, I'll get 4 into 3, I'll get 12. Now there is a shortcut. What is a shortcut? I can write 4P2 directly as 4 into 3. I'll have to start from 4 and I'll have to write 2 terms, right? 4, the next reducing term is 3 because here r is equal to 2. So I'll have to take it 2 times, 2 factors basically. So you get 4 into 3 is 12. So directly you can arrive. Let's take another example. Say we have 6P3, right? Example. We'll get 6 factorial by 6 minus 3 factorial, which is 6 into 5 into 4 into 3 into 2 into 1. And 6 minus 3 factorial is 3 factorial. And what is 3 factorial? 3 into 2 into 1. You cancel this, we'll get 6 into 5 into 4, right? Get some answer. If I use a shortcut now, if I use shortcut, there are 3 terms. R is equal to 3 here. So I will start with 6 and I'll keep on decreasing 3 times until I reach 3 terms or 3 factors. So I get the same answer here. 2 more things that we need to note. NPN is equal to n factorial and np1 is equal to n.
Let us take an example, say 4p4.
4p4 is 4 factorial by 4 minus 4 factorial. Remember one more thing, 0 factorial is always 1. So this will be 4 factorial by 0 factorial, 4 factorial itself, right? So what we have, 4p4 is 4 factorial. So npn is n factorial. Now we'll take the next one, np1. Say 4p1 we take. 4p1 will be 4 factorial by 4 minus 1 factorial, which is 4 factorial by 3 factorial. So one more technique here is, you don't have to expand till 1. You can just stop it when you reach the denominator. For example, you stop it when you reach 3 factorial. 4 into 3 factorial. So this 3 factorial and 3 factorial will get cancelled. You're left with 4. So what did we get? 4p1 is nothing but 4. And what is 4? 4 is nothing but n. N is equal to 4. So therefore, npn is n factorial and np1 is n itself. Now let's take another example. So we have given a word rose. We'll have to find how many ways the letters of this word rose can be arranged, right? Roughly, we can say R-O-S-E, we can say R-S-O-E, then we can say R-E-S-O, R-E-O-S. So there are multiple ways. We have to form the list of words that can be formed with these letters without any repetition. So for example, we can't have R-O-O-S. We can't have R-E-E-S. There is no repetition allowed, right? In this case, if we have to take the first letter, we have 4 letters. We'll have to take 1 out of 4. So we can take any of the 4 letters. So we get 4 ways. If we choose one letter, if we choose the first letter, how many letters do we have for the second letter? We are left with 3 letters. Now if we choose first letter and second letter, how many letters do we have? We have 2 letters. 2 letters, and you'll have 2 ways to choose those letters. And for the last letter, you just have 1 letter left. So how many ways to choose that 1 letter? Only 1 way. So now, using our multiplication principle of counting, this is one operation. Choosing first letter is one operation. Choosing second letter is one operation. Third operation, fourth operation. We have to club all the operations to form one word, right? So you'll have to multiply. So how much do we get? We get 24 ways, or we'll get 24 words out of these 4 letters, and none of the letters are repeated. There is an alternate logic of determining this, right? This was one way. There's another way, right? Choosing first letter. How many letters do I have? 4 letters. How many do I have to choose? 1 letter. So it will be 4p1. Similarly, for second letter, I have 3 letters because I've already chosen the first letter. So I'll have 3. How many letters do I have to choose? 1. Third one, I have 2 letters. How many do I have to choose? 1. And here it will be 1p1. So what is 4p1? I told you, np1 is always n itself. So 4p1 is 4, 3p1 is 3, 2p1 is 2, and 1p1 is 1. I have to multiply all of this. So I get the same answer. So this is another alternate logic. Now I'll take the same example. Rows. This is, the earlier one was case 1. Now I'll take this as case 2. In case 2, repetition is allowed. Now I have to find out number of words that I can form with these 4 letters. Number of words that I can form with these 4 letters with repetition. So if I have repetition, now the technique will change. So to get the first letter, I have 4. To get the second letter, I still have 4, because it doesn't matter how many other times I used any letter, I still have the entire list to use. So it will still be 4. Here also I'll have 4 ways. Here also I'll have 4 ways. So I'll multiply all of this. So what is the total number of ways? 4 into 4 into 4 into 4. So this is with the repetition. Let's take one example. How many 3-digit numbers can be formed from 1, 2, 3, 4, 5, 6 if digits can be repeated? So let's draw this 3 digits. 1, 2, 3. 3 digits. And numbers that we have is 6 numbers we have from 1 to 6. So how many numbers are there to choose the first number? 6 numbers, which means I have 6 ways or 6 choices that I can make. Now, here the digits can be repeated, right? So to choose the second digit, I still have 6 numbers. So 6 ways. Third digit also have 6 ways because I can repeat. I can have 1, 1, 1, 2, 2, 2, right? Any combination. So now what I have to do, I have to multiply all of this using multiplication principle because I'm trying to find 3-digit number, and to find the 3-digit number, this is one operation, this is one operation, this is one operation. Operation to choose first digit, second digit, and third digit. All these 3 operations are multiplied to get the 3-digit number. So what is the total number of ways? Total ways to form 3-digit number is 6 into 6 into 6. Now I'll alter the same example and say digits cannot be repeated. Now what will happen? Cannot be repeated. So I'll choose the first digit. I have 6 digits. So there are 6 ways of choosing it. It can be either 1, 2, 3, 4, 5, 6. Second digit, 1 digit is already chosen. Now how many I have? 5, right? And for third digit, 2 are chosen. How many are left? 4. So 5 ways of choosing, 4 ways of choosing, and 6 ways of choosing. I multiply all of this. What do I get? Total ways is 6 into 5 into 4. This is without repetition. This is with repetition. Let's go through third variation or third case of permutation related problems. This is a case where certain number of things always have to occur together. For example, we have been given the word daughter. In this 8-letter word, we'll have to find how many arrangements can be made so that we can find different combinations of this particular word. We can arrange all the letters in this word in different ways. But they've given also one condition. We have to arrange it in such a way that all the vowels are together. Right? Now, how do we solve this? Let's first step, how many letters do we have? We have 8 letters here. Right? And how many vowels do we have here? We have A, U, E. We have 3 vowels. That is A, U, E. Now we will consider A, U, E as one unit. Now you will wonder what is these units that have come up now. Basically assume that this is one letter. Assume that it is one letter for time being. Right? Then how many letters are left out? We have 5 letters. Remaining letters is 5. Right? 5 letters. And then we will have to add this one unit. So how many do we get? 6 units. Basically, we have 5 letters and one unit, that is where all 3 vowels are together. We will have to arrange this. So how many ways can we arrange 6 units? 6p6. Because n is 6, r is also 6. Because we have to use 6 letters to form 6-lettered word. Right? So 6p6. What is 6p6? Nothing but 6 factorial. So this is step 1. Let's go to step 2. This AUE, it's one unit, but within this units, you can arrange in different ways. You can have AUE, AEU, EAU, EUA, and so on and so forth. So how many combinations do we have? We'll have 3p3 or 3 factorial. So number of ways vowels can be arranged is 3p3 or 3 factorial. This is our step 2. We'll have to multiply this too, right? So total ways, right? Total ways of arranging 8-lettered word with vowels together is 1 into 2, which is 6 factorial into 3 factorial. That is 4320 ways. So let's take the fourth variation of permutation related problems. What is the fourth variation? When certain number of things don't occur together. So earlier we saw third case where certain number of things occur together. For example, we saw that vowels had to be together to form a 8-letter arrangement in the word daughter. Now we will do the same thing where it says that ovals do not occur together, right? Now, how do we solve this? First thing is we'll have to find total number of arrangements minus number of arrangements with ovals together. So first get the total number of arrangements, then find the number of arrangements with ovals together. We subtract them and then we get number of arrangements where all ovals are not together. So what is the total number of arrangements? We have 8 letters. So arrangements with 8 letters would be 8 factorial. That is nothing but 8p8, because we are going to form a 8-lettered word using 8 letters. So 8p8, n is equal to 8 and r is equal to 8. And what is 8p8? Nothing but 8 factorial. And what is number of arrangements with vowels together? This is a two-step approach. First you find arrangement with vowels together. And then second step is consonants together and 1 unit of vowel. We multiplied these two and we got number of arrangements with vowels together. So in the last example, we got the answer as 4320. So if you subtract both of this, 8 factorial is 36,000 as the answer. So there are 36,000 ways in which we can arrange 8-lettered word daughter without having vowels together. Let's solve fifth case of permutation related problem. This deals with like things. Now, what do you mean by like things? Let me take an example. Say we have the word roo, R-O-O. How many ways can you arrange these letters to form 3-lettered words? How many arrangements can you make? It will be 3p3, nothing but 3 factorial, which is 3 into 2 into 1, which is 6 ways, right? So what are the 6 ways? It will be, say, for example, let me consider first O and second O, just for identification, right? I would call it as O1 and O2. This is first O and second O. How many ways can I arrange? R, O1, O2, R, O2, O1. Then we can arrange it in O1, R, O2, O2, R, O1. Then we can have O1, O2, R, O2, O1, R. So we'll get 6 ways of arranging 3 letters. Now, does it really matter if this is O1 or O2 or O2 or O1? It doesn't matter whether I'm putting first O here and second O here, second O here and first. It doesn't matter. Actually, here this becomes a duplicate. This becomes a duplicate. This is also a duplicate. So actually there are only 3 ways. If I remove the duplicate, so I'll get, in this list I get ROO, in this list I get ORO, in this I get OOR. Actually there are only 3 ways. So now what does this permutation of like things state? It tells total number of ways that you can arrange objects when there are like objects. That is objects of similar kind or objects of repeated kinds. In that case it is n factorial by x factorial to y factorial to z factorial. This can go into any number. This x factorial is nothing but objects of one kind, objects of second kind, objects of third kind, right? All the repeated kinds is what we put in the denominator. So in this case, what is n factorial? What is n? N is equal to 3. So if I use this particular formula, I'll get total ways is equal to 3 factorial by x factorial to y factorial. Now what is x factorial here? It is nothing but the number of repeated letters. How many letters are repeated here? One letter is repeated how many times? 2 times. So there are 2 O's, right? There are 2 O's. That means it will be 2 factorial. So what will happen? 3 into 2 into 1, 2 into 1. This will get cancelled and you'll get 3. So we got 3 ways. But this is what is right. Because we are supposed to get 3 ways when there are identical letters or identical objects. So this is what we call as permutation of like things. Now let's take another example. In how many ways can 4 red discs, 3 blue discs, 2 green discs be arranged if the discs of the same color are indistinguishable? So there are 4 red colored discs, 3 blue colored and 2 green colored discs. In how many ways can all of these discs be arranged? Why is it called as indistinguishable? That means we cannot differentiate between this disc, this one and this one, because all are of the same color and same shape and size. We can't distinguish. Similarly, blue colored, green colored, we can't distinguish. So in this case, how do we find the number of ways? We'll use this particular formula. What is n? N is 9 for us. 4, 7, 9. N is 9. So total ways would be 9 factorial by how many repeated kinds we have? We have 4 red discs. So 4 factorial. This is for red disc. Then we have 3 blue discs. So that is 3 factorial. This is for blue. And then 2 green discs. This is for green. So this is the total number of ways. We'll have to always put the repeated objects in the denominator. So we will get, what is 9 factorial? 9 into 8 into 7 into 6 into 5 into 4. I'll stop it here because I don't want to calculate unnecessarily. I will cancel with the 4 factorial in the denominator. 3 factorial write as 3 into 2 into 1. And 2 factorial is nothing but 2 into 1. So I'll cancel this. 3 2s are 6. This will get cancelled. 2 will get cancelled with 8. Will become 4. So you'll get 9 into 4 into 7 into 5, which is 1200. So we have 1200 ways. So let's take an example to determine permutation of like things. What's the example we have? Find the number of arrangements in letters of word independence. In how many ways of these arrangements can words start with P? There are two parts to this question. One is you have to find number of arrangements in the word independence. And then we'll have to find how many ways can we have words starting with P. So first let's find total arrangements. So what is total arrangements? How many letters do we have? We have 12 letters. So 12 factorial. Why is it 12 factorial? Because you are forming words with 12 letters, taking 12 letters at a time. So it is 12p12, which is 12 factorial. And how many repeated kinds we have? Let's find out. N is equal to, how many times does it happen? 3 times we have N. D is 2 times. E is 4 times. So we'll write all the repeated kinds here. 3 factorial into 2 factorial into 4 factorial. This is our total arrangements. So when you calculate, you're going to get a big number, 166,200. Now, we'll have to find words starting with P. Words starting with P. That is, P will be in the first position and the remaining 11 letters will be here, right? So, what will be the arrangements for these 11 letters? It will be 11 factorial. See, we will not take the unit concept here because the position for P is fixed. It's going to be in the first place, right? There is not going to be any further arrangements for this P. So it's only going to be 1. So now 11 factorial because we have 11 letters and we have to put it in 11 places. 11 letters in 11 places will be 11p11. That is nothing but 11 factorial. So words starting with P, the number of arrangements for words starting with P would be 11 factorial by repeated kinds. What is the repeated kinds? 3 factorial, 2 factorial and 4 factorial. 138600. Okay, so let's remember this values because we will need it in the other parts of the problem. Now let's solve a second problem which says ovals to be together. How many vowels do we have in independence? We have I, we have E, that's all. We have I and E. Now how many I's we have? 1 I and 4 E's. So this becomes 1 unit because all of these vowels have to be together. So how many letters are left over? Let's say this is I, E, E, E. This is 1 unit. And how many letters are left over? 12 minus 5. 7 letters are there, right? We'll have 7 letters here, right? Now here we'll have to put the unit concept. Why? Here this 1 unit, because within this unit you can have multiple ways of arranging these vowels. For example, you can have I, E, E, E or E, I, E, E or E, E, I, E and so on. You have different arrangements, right? So we have 5 letters here. So how many arrangements? We'll have 5p5, which is 5 factorial, right? And then we have 7 letters here. So this will become 7 units. And we have to consider this as 1 unit. We'll have to add it here. So it's totally 8 units. Now we'll have to get number of ways in which ovals can be arranged in 1 unit. What did we get? 5 factorial, right? And we'll have to find the repeated kinds also, right? What is the repeated kinds? Repeated kinds is we have 4 E's, so 4 factorial. Let's not forget this. Let's call this as number 1. Second one is number of ways other letters can be arranged along with vowels. So this was only with vowels. Now this is vowels and other letters. So what do we get here? We have 8 units. So it will be 8 factorial. By how many repeated kinds we have? We have n. N is 3 factorial. We have d. D is 2 factorial. We will not consider e because e is already considered in this vowels. So this is step number 2. The final step is total ways is 1 into 2 by using multiplication, because we are trying to find a word with different arrangements of letters. So basically you're finding one group. So you're going to multiply vowels and the other letters. So you're going to get 5 factorial by 4 factorial into 8 factorial by 3 factorial into 2 factorial. So you're going to get total number of ways is 16,800. Let's take third part of the sum, which tells you have to find the number of arrangements with vowels not being together. So in this case, vowels shouldn't be together. In the earlier case, vowels had to be together. So what is the step 1? We have to find total arrangements minus vowels together, right? When you take the total arrangement and subtract with vowels together, you will get this one. That is, you will get the number of arrangements where vowels are not together. So we know we got the total arrangement in first step, right? What was the total arrangements we got? 166, 3200. And vowels together we got 16,800. So let's look at the fourth part of the problem, which says word should start with I and ends with P. So now what do we get? So word should start with I, end with P. So the remaining letters 10. 10 letters are placed in the middle. Now, how many ways are there for 10 letters? 10 P, 10, which is 10 factorial. Now, I can be arranged in one way, P can be arranged in one way because their positions are fixed. So there is no unit concept here because there is only one way that you can arrange the first letter and the last letter. So you multiply this and you get the total number of arrangements. Again, we have to find the repeated kinds, right? 10 factorial. How many repeated kinds we have? We have 3 n's, 3 factorial, 2 d's, 2 factorial, and we have 4 e's, so 4 factorial. So total ways is equal to 10 factorial by 3 factorial into 2 factorial into 4 factorial, which is 12,600.